All right, students. Okay, so we left off on this problem here. Just as a reminder, so when we put 0 into x, we're going to get 0. And then when we put 0 into natural log x, we get negative infinity. And how we got that is by looking at the graph of natural log of x. If we look at the graph of natural log of x, which you should remember, it's this graph right here. As we approach 0 from the right, then that is going to be negative infinity. So this is an indeterminate product, which therefore we get to use L'Hopital's rule because that's an indeterminate form. The only problem is that we have to get this in fraction form, which it's not right now. So how do we do that? Well, I can take the reciprocal of one of these and put them in the denominator. So I'm going to do this. Limit as x goes to 0 from the right of natural log of x divided by 1 over x. So when you do that, if you take the reciprocal of this or multiply it by the reciprocal, that is going to give us the exact same expression. So both of these expressions are equivalent to each other. Now, I can apply L'Hopital's rule. So I'm going to do that in this step right here. Okay, I just write that just so that you know what step I actually did that in. So now I'm going to do limit as x goes to 0 from the right. And the derivative of natural log of x is 1 over x, divided by the derivative of this is going to be negative 1 over x squared. Now, before I put 0 in again, it's better to simplify. So if I simplify this, limit as x goes to 0 from the right, I can multiply this by the reciprocal. So this is going to be negative x squared over 1. And when I do that, it's going to give me a negative x. So that is my expression simplified. And so when I have it simplified, if we put 0 in, that is going to be 0. And so that is the answer to our limit problem. And we applied L'Hopital's rule just once. Okay? Now for our next example is this expression. I have limit as x goes to pi from the left of sine x divided by 1 minus cosine x. So now, if we just substitute pi in for sine or in for x and sine of pi is 0. Cosine of pi is negative 1. So I'm going to have 1 minus negative 1, which is 0 divided by 2. And is that an indeterminate form? No, 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 no! That is not an indeterminate form. So therefore, do we use L'Hopital's rule? No. In fact, actually, this is just equal to 0, because 0 divided by 2 is 0. And that's our answer. Now, the reason why I went over that one is because people oftentimes get so used to using L'Hopital's rule that they think that every time they see a limit, they get to use L'Hopital's rule, and that is not the case. The only time you can use L'Hopital's rule is when you have an indeterminate form, which this is not. Okay? All right. For our last example here is this expression. Limit as x goes to pi over 2 from the left of secant x minus tangent x. So we probably need to remember what our graphs look like because we're not talking about at pi over 2, but we're talking about as we approach pi over 2 from the left. Because actually, tangent of pi over 2 is undefined. So what we're going to do is we're going to recall the graphs of secant and tangent. Secant, I know it's the reciprocal of cosine. So here is my cosine graph, like this. And here is pi over 2. And I remember that wherever cosine hit the x-axis, there were asymptotes. And then secant was actually these guys. Okay, so now if I look at secant, as I approach pi over 2 from the left, where is secant going to? It is going to infinity. Okay, now let's look at the tangent graph. If I look at tangent looks kind of like a cubic, but it has asymptotes. So at pi over 2 and negative pi over 2. And then, of course, it repeats. Whee! And 3 pi over 2. So now I'm looking as I approach pi over 2 from the left. So I look, ooh, and it is going off to infinity. So what do we have? Infinity minus infinity. And let's go through my list. And that is right there. It's indeterminate difference. So that means that we get to apply L'Hopital's rule. But again, L'Hopital's rule, we have to use, it has to be in a fraction. So I need to get this in fraction form. So here we go. Luckily, we know what these are in fraction form. This is limit as x goes to pi over 2 from the left. And what is secant? Secant is 1 over cosine x. What is tangent? It is sine x all over cosine x. Now, I have these both in fraction form. Is that what I'm supposed to have before I do L'Hopital's rule? Let me see. No. Even though these two are fractions, it has to be just one fraction, one numerator and one denominator. I have two numerators and two denominators, so I need to combine them together. So I will have limit as x goes to pi over 2 from the left, and this is going to be 1 minus sine x divided by cosine x, since they had common denominator. If I want to check again to see if I have an indeterminate form, we can see. Let's see, if I do pi over 2, sine of pi over 2 is 1, and so 1 minus 1 is 0. And if I put in pi over 2 for cosine, that is also 0. So I have 0 over 0. So I still have a situation where I can use L'Hopital's rule. So now let's use it. Limit as x goes to pi over 2 from the left. And when I do that, I take the derivative of my numerator, which is going to be negative cosine x, divided by, I take the derivative of my denominator, which is negative sine x. Now, this is the same thing as positive cotangent x. You can simplify that, or you can just put pi over 2 in, and you should be fine. So if I put pi over 2 in, well, these are positives now. So cosine of pi over 2 is 0, and sine of pi over 2 is 1. And so what is 0 over 1? It is equal to 0. And that is the answer to that problem. Okay. Now, there is another situation that we have, which are indeterminate powers. So AB only needs to know these ones, quotients, difference, and products. But BC does need to know how to do indeterminate powers. So I am going to do a video also for situations where we have indeterminate powers. Okay, good luck.